we look at the data science life cycle. So data science life cycle comprises of all of these steps. First, we have data acquisition. Then we have data pre-processing. After that, we will apply machine learning algorithms. Then we will evaluate the patterns which we get after application of these machine learning algorithms. And finally, we would have to represent or show the result. So let's start off with the first step, which is data acquisition. So as I have told you, in this present day and age, data is not structured. Data is unstructured and it is present in multiple formats, and this data comes from multiple sources. So if we would have to solve a problem statement or a business statement, we would have to collect all of this data from different sources. So as you see over here, so this PDF file might be coming from source 1. This Excel file might be coming from source 2. This document might be coming from source 3. So you would have to collect all of these data which are of different types, different formats, and you would collect them and store them at a central storage repository. So you can call this central storage repository as your data warehouse where you're storing all of your acquired data. Now you acquired this data, but the problem is you've got multiple data sets or multiple data points, and all of these data points have different structure. So what you do is you integrate them into a single data structure. So what you do is, since all of these data files have different formats, you will integrate them in such a way that all of them would be of the same format, and that you will store in your data warehouse. So now after you have integrated your data, you can go ahead and find your target data. So whenever you're solving a problem statement or a business statement, you would have to keep in mind that not every data point is essential for you to solve your problem statement. So let's say over here in your data warehouse, you would have 100 files. Now out of these 100 files, only around 30 files would be important for you. Only these 30 files would have the essential information which would help you to solve the problem statement. So you will take only those 30 files, and those 30 files would be your target data. So once you have acquired your target data, you would have to pre-process your data. So this stage is known as exploratory data analysis, and this is the stage in the data science life cycle which takes up most of your time. So normally in the data science life cycle, if let's say if you have a bar from 0 to 100, then 70% or let's say greater than 50% of your time goes over here, which is pre-processing. Because what you've acquired right now is your raw data, and you have to convert your raw data into tidy data on which you can apply your ML algorithms. So under exploratory data analysis or pre-processing, you have two main tasks, which are data manipulation and data visualization. So let's start off by understanding what exactly is data manipulation. So in data manipulation, let me give you an example. So let's say your boss comes up to you and gives you this huge spreadsheet, which let's say comprises of around 10,000 columns and 1 million rows, and asks you to find out all of those employees whose salary is greater than 10 lakh rupees and whose age is greater than 30. So what do? Do you actually manually go through every single record and check the salary and age of the person? Well, that would be extremely time consuming and also stupidity on your part. So you wouldn't do that. So this is where you will use different data manipulation techniques using languages such as Python, R, or SQL. So here, using these languages, all you have to do is just write one line of code, and with the help of this one line of code, you will be able to extract all of the employees whose salary is greater than 10 lakh rupees and whose age is greater than 30. So this is a simple example of data manipulation. Then we have data visualization. Now, again, if we take the same example of this huge Excel sheet, and if you are supposed to find out insights from this Excel sheet, so do you understand anything if you just look at the sheet? Obviously not, right? Because it's just a bunch of numbers or maybe a bunch of text which is present in this tabular data. And this is a huge data set. So what do? Instead of just looking at this table, what if you actually make a plot out of it? What if you make a bar chart or a scatter plot or a histogram or a box plot out of it? So now, if you look at the picture, you will be able to find insights easily when you compare it to just looking at the table. So as they say, a picture speaks 1,000 words, and that is why data visualization is an extremely important part of your data science lifecycle. So this is your data pre-processing stage. So you have got your data, you have acquired your data, and you have pre-processed your data, and you have converted your raw data into a tidy format. Now, after doing that, once you have the tidy data, this is where you will go ahead and build your machine learning algorithms. So we'll understand what exactly is machine learning going ahead. So just for now, as it is stated over here, consider machine learning to be application of intelligent algorithms to find meaningful information from the data. So depending on the problem statement, you will go ahead and apply any of these ML algorithms. So let's say if the problem statement asks you to classify something into different groups, you will go ahead and use a classification machine learning algorithm. Similarly, let's say if your problem statement asks you to predict something on the basis of something, you will use a regression algorithm. Again, let's say if you would have to cluster your data into different groups or cluster your data into different segments, you will use a clustering machine learning algorithm. And now, after you apply these ML algorithms, you will obviously get a result. But you cannot be sure that the result which you get is correct and useful. So this is where you would have to evaluate the result which you get. And this stage is known as pattern evaluation. So whatever result you get, so you have your data, you have your tidy data, you are applying your ML algorithm. After you apply your ML algorithm, you'll get a result. And this result you would have to verify properly. So here what you do is you check for the accuracy of the result, you check for the correctness of the result, and also you check for the usefulness of the result. So let's say you have a result, but the accuracy of the result is only 35%, which is less than 50-50 probability. So you've built the model, you've done all of the hard work, but then again, your ML model gives you only a 35% accuracy. Now, which would mean that the model which you've built is extremely baseline and you would have to tweak it. So also, when I say the model which you've built has to give you useful results. So even though let's say you've built a model, it will give you a result which is accurate. But then again, let's say if the result which you get doesn't really solve your problem statement, then there is no point of using this result. So this is also something which you would have to keep in mind. So you will do pattern evaluation, and after evaluating the result, if you see that the result which you get is correct and useful, that is when you will take that as the final result. And once you get the final result, you can go ahead and show out that result in the form of simple aesthetic graphs to your stakeholders or to your clients. And this stage is known as knowledge representation. So your stakeholder or your client might not be that technologically savvy. So if you just give him the technological jargon of what you found out in the result, obviously your stakeholder or your client would not be able to understand much. So you would have to dumb it down, you would have to simplify it by using aesthetic graphs, and you will add the highlights of what you found out in these graphs, and that is what you will present as your final result. So this is your entire data science life cycle.